Completion time. Paragraph for question 1 to 3. Okay, good. A U-shaped uniform frame of rod ABCD of each side of length L and mass M is hinged from one end A of one of its limb as shown. Okay, तो ये frame है. Fine. Okay. When D is the level in the level of 8 and taking the horizontal direction AD as x-axis, अच्छा तो ये horizontal है. और vertical direction upward as y-axis, तो ऊपर y-axis है. Okay. X center of mass of the given system is इसका center of mass. Got it. इसका क्या रहेगा? Just add ml upon 2. Okay, over there ये उधर आ जाएगा. And then this thing is that that's kind of not good. अच्छा ये थीटा पर है ना? Right. तो ये क्या? Just downward कितना? Just L cosine theta. So I think already got L cosine theta. फिर इसका right. Okay, it's like L upon 2 cosine theta. फिर प्लस L upon 2 cosine theta और फिर इसका मास आएगा which is at L cosine theta. And then that upon 3, right? Which is like L cosine theta times 1 upon cosine of 1 plus it's 2/3. So 2/3 L upon 2 cosine theta, that's y actually negative of that thing. So that's the y coordinate. और x coordinate क्या रहेगा इसका? It's just ये तो मर गए दोनों. It's just at L upon 2. So L upon 2, comma L negative 2/3 L cosine theta. And then what's the z coordinate? So ये x है, ये y है. Z will be in inward direction. Got it. इसमें negative आने वाला, right? Okay. So x center of mass, that's pretty easy, just L upon 2, right? Because ये मर जाएगी, just L upon, of course. So A, first का answer A. Okay, और क्या है second का answer? The phi center of mass, which is negative 2/3 of right. Okay, cosine theta कितनी चाहिए? And do we not know cosine theta? हाँ, but cosine theta क्या है? We need that. Otherwise अपन कैसे कर पाएंगे इसको? Why? There should be a cosine theta somewhere. Okay, so at theta equal to 0 or something, I guess. Hinge from one end and A, okay, and in A, okay, one of its lives, okay, when D is the level of A, subja, so D is at level of A, and taking horizontal, shit, oh shit, तो ये सब कुछ vertical, okay, समझा मैं. All of this is just stupid because ये सब कुछ vertical plane में हो रहा है. तो actual में कैसे चाहिए? That theta is when it is displaced. Actual में स्टार्ट करें अपन थीटा इक्वल टू 0 पे, मतलब कि ऐसा होगा ना, राइट? ओके, तो यहाँ पे ए होगा, ये डी है, एंड दिस कंप्लीट प्लेन इज जस्ट एक्स वाई प्लेन, राइट? ऑफ कोर्स. देन ऑफ कोर्स सेंटर ऑफ मास का एक्स जस्ट ए एल अपॉन 2 रहेगा, एंड द वाई सेंटर ऑफ मास इज व्हाट? एल अपॉन 2 नेगेटिव, ओके, एल टाइम्स क्या? नेगेटिव 1 अपॉन 2, नेगेटिव 1 अपॉन 2, और यहाँ पे नेगेटिव 1 आएगा आई गेस, एंड ऑल ऑफ दैट अपॉन 3 आई बिलीव, राइट? या व्हिच इज, सो नेगेटिव 2 अपॉन 3 नेगेटिव 2 अपॉन 3 एल व्हिच इज बी. थर्ड क्या है? Okay, if the system is displayed at small angle from equilibrium position, the time period of oscillation will be. ठीक है, system is displaced किया, then what's the time period of oscillation? I guess you can do kinetic energy conservation or something like that, right? Because or maybe something like that, right? अच्छा, at theta, what's the torque or something? I mean, okay, inertia is not that hard to figure out, is it? Like, okay, you need inertia anyway. So इसके about inertia कितना रहने वाला है? Ah, shit, this is just going to be hard. Time period of oscillation is, we'll need the torque anyway, right? ठीक है, let's try to do it. So अपनी अब जो फ्रेम रहेगी, it's like this. यहाँ पे एंगल थीटा है, this is L upon 2 over there. ये जो है just this is the thing. So torque जो रहेगा just R plus F about this guy. ये नीचे mg लगने वाला है. This is like this guy is R vector. Oof, this is not going to work unless मैं कोई और तरह से कर पाऊँ. Oh yeah, in this particular frame of, okay, so उस coordinate frame में हमारा जो mg force है, actually like in what direction can split this, right? यहाँ पे और यहाँ पे. got it. It's just like this. Yeah, that, and then सिर्फ external forces का देखना है, और फिर तुम इसको कैसे break कर रहे हो? This is like theta just mg sin theta. So just okay, so just mg sin theta in the downward direction, right? So अगर मैं इसको ऐसा रखूँ normally, अब उसमें रोटेट कर भी दिया है, बट देन दिस इज द थिंग, एंड देन तुम्हारा एक्चुअली जी वेक्टर यहाँ पर है, विच इज ब्रोकन डाउन एज g sine theta. Wait, that's theta. G cosine theta, right? Yeah, g cosine theta in the downward direction, and then its direction is just g sine theta, right? Got it. So इसका mass का just L upon 2. Okay, whatever. Damn it. So you can just g. This is kind of complicated. This is a x coordinate. Yeah, x coordinate is sine theta. Y coordinate is just negative cosine theta. This is our f vector for all of these. Okay, I should say a vector. So be it. Okay, that's awesome. And or you could just do this thing m vector, right? Sorry, g vector. And then फिर इस पूरे इसका center of mass we now know. So yeah. Torque about center of mass is just zero, right? It happens to be zero because, or is it? Is it zero? Wait, वो point of fixed है ना? Just doing what? You're just doing this thing integration of. It's getting complicated. About center of mass and because of center of mass, and that's the torque. Oof, this is hard to figure out. Yeah, वो कैसे करूँगा मैं? ऑफ सेंटर ऑफ मास निकालना इजी है, बट देन अबाउट सेंटर ऑफ मास इसको ब्रेक करो यार, इसको 3 रॉड्स में ब्रेक करो. दैट्स द ओनली वे. जो ये फोर्सेस रहने वाले इंटरनल फोर्सेस, गेट rid of those. उससे अपने को टॉर्क नहीं मिलता है एनीवे. सो जस्ट डोंट थिंक अबाउट दोस. जस्ट एक्सटर्नल फोर्सेस का देखो. सो यहाँ पे जी वेक्टर का जो भी रहेगा, इसका r1 वेक्टर, इसका r2 वेक्टर, एंड देन m. या ओके, सो बेसिकली वो सेंटर ऑफ मास ही हो गया ना, वो कॉम्बिनेशन जो रहेगा, राइट और नॉट. Oh right, okay. Talk about center of mass. इसके ये जो चीज है, because of that there will be something, right? It's kind of complicated. We want with this guy like r vector cross this guy, right? इसका r vector cross our जो भी इस पे f vector लगने वाला है, that thing. So similarly इसका, then that will be the thing. Okay. Logically कैसा होगा कि ये just RCOM cross F vector on the complete mass. But then we know कि center of mass के about जो torque रहता है, we also have to take that into account because like about this point. Think अगर अपन ये इस वाले के बारे में भूल जाए, इस फोर्स को अपन भूल जाओ completely, then जो इस पे अपना क्या जो बाकी जो फोर्स रहेंगे, जो ग्रेविटी वगैरह है, या फिर या जस्ट बिकॉज ऑफ ग्रेविटी जो फोर्सेस लगने वाले हैं, मतलब इंटरनल फोर्सेस तो वैसे भी कुछ नहीं कर सकते और ये फोर्स कुछ नहीं कर सकता. जस्ट ग्रेविटी की वजह से उस पे टॉर्क लगेगा अबाउट दिस पॉइंट, राइट? सपोज ये हिंज नहीं होता, दैट एक्सप्लेन्स इट. सो अबाउट सेंटर ऑफ मास जीरो हो जाएगा इन दिस केस, यानी जस्ट सेंटर ऑफ मास. ओके, गॉट इट. आर वेक्टर क्रॉस एफ वेक्टर, आर वेक्टर पर निकाल चुके हैं. इट्स जस्ट क्या था, एक्स कोऑर्डिनेट इज l upon 2, देन और ये रोटेटेड रेफरेंस पे बाय द वे, एंड देन ये just negative 2l upon 3 था, and then this crossed with ये वाला vector which is just g sin theta, g cosine theta. Okay, got it. It's just gl 1 upon 2 comma negative 2 upon 3 cross s comma c, right? Well, yeah, which is what, so I times I umar gaya, just I times t, right? Just like k, it's just k hat पे कितना, just 1 upon 2 c पे यहाँ पे नेगेटिव आएगा जिसका पॉजिटिव 2/3 of s. Got it. So approximately कितना, this is just 2/3 or s and then gl, right? So 2/3 gls, but this times of 3m because that's the actual force. So ये गया is just this thing, but torque is just 2gl sin theta. Got it. Okay, awesome. Wait, okay, m भी मर गया ना, m भी लगेगा. So 2 mgl sin theta, or that's just equal to I alpha. What's our inertia about this point? At least that's constant. Yeah, just ml squared upon 3, then plus इसके लिए, wait, our axis is like what, sx, yeah? Okay, got it. This is kind of weird. So like this is about that x, just ml squared upon 3, but then you're moving like that, so just ml squared upon 3, and then plus तुम you move करो ml squared से, and then about this guy ये एक्सिस के अबाउट कितना रहेगा प्लस ml squared upon 3, but then you're moving like this, which is like plus ml squared. Got it. Just like ml squared 3 इसमें आ गए, 3 ml squared, that's what inertia. Just 3 ml squared times alpha, or negative जो भी है, just alpha is equal to what, negative, और sin theta is approximately theta itself is negative theta times ये m तो हो रहा है just what 2g l upon 3l squared, तो ये एक l बचेगा यहाँ पे just right. So our omega is just square root of 2g upon 3l. So what do you want, by the way? Time period of oscillation is 2 pi upon omega, so 2 pi square root of 3l upon 2g. Which, oh god, इसमें 5 क्यों आ रहा है for some reason? Is this supposed to be 5? No. Unless h is 5 हो. This is like 3 ml squared, right? Because, huh? Total mass is just that. Isn't that right? 7 squared upon 0 at that point. Go up, of course. Something's not right about this. This length is L. We know that. Just right. It's got to be just this thing. So it should be just 2G, right? Not 5G. 5G कैसे आ रहा है इसमें? How can that be correct? ये जो चीज है, this is इसका ml squared upon 3 रहेगा about that, of course. इसका क्या रहेगा? Just ml squared upon 3 plus ml squared, because you know about this point is ml squared upon 3. फिर center of mass से अपन करके ऐसा जा रहा है, ऐसा जा रहा है. Yeah, that should be the thing, of course. Similarly इसके लिए I don't get it. क्या गलत कर रहा हूँ मैं? इनर्शिया तो अपना करेक्ट आ रहा है, अनलेस अपना टॉर्क गलत आया हो. अपना टॉर्क क्या है? दिस थिंग. So cosine theta is also like, oh shit. Cosine theta is 1, right? Uh-oh. Yeah. Not good. We can't just, oh, shit. Right. Okay, something's not going correct. ये कैसे आ गया पे? This should not be correct. This should not be correct. See cosine theta over there. You know, for all of this, there is that over there. So, right. Okay. Understood. So वो एक चीज constant यहाँ पे आएगी, but otherwise it's just this thing, right? Yeah. वो at some theta it will just be equilibrium and just like 2/3. It's still just 2/3 GL, and फिर उसके things of 3. Yeah. Okay. You just want that as a 3m, of course. So just mgl and then 2 mgl sin theta, right? Yeah. So it should just be square root of 2 upon that, and वो क्यों नहीं है फिर यहाँ पे? Let's कुछ इसमें गलत हुआ हो. 5. I don't understand this. Let's move on. Position. Ah, shit. Got it. समझा मैं क्या गलत हुआ. Theta equal to 0 is not equilibrium, right? Okay. So yeah, you got this part correctly, but torque अपना जो है is not okay. Got it. Equilibrium position क्या होगी? When this is equal to 0, right? फिर इसमें अपन plus small theta extra डालने वाले, right? Yeah. So like 1 upon 2 cosine theta फिर cosine theta फिर minus sin theta, right? So just like C, and then जो नया C आएगा, so like that just थोड़ा सा छोटा रहेगा ना, so like approximately 1 कर डालो इसको, फिर then minus 1 upon 2, इसमें दोनों में sin आएगा, so like sin of ये जो भी let's just say थीटा इक्विलिब्रियम, इसमें phi बोल देता हूँ, like cosine phi, and then cosine theta is just like sin phi, sin theta. We need to figure this out. Are you serious? Okay, ठीक है ना? I guess there's no other way. ये तो मर जाएगा, just I cross, sorry, J cross. Yeah, okay. Okay, so like what, 1 upon 2 C phi is equal to negative 2/3 of S phi. Phi is somehow an obtuse angle. Does that make sense? I don't think it should. Phi is an obtuse angle. Unless it's negative, of course. That would make sense. Okay. Right. Yeah. Unless it's negative. Wait, nahin. But then we know that it should just be. हमें negative एक चाहिए था. Where's the negative? Okay, ये negative g को साइन है ना? Along y, negative. That's why यहाँ पे positive आएगा. So चलिए ये पहले यहाँ पे नेगेटिव है फिर पॉजिटिव, गॉट इट। सो क्या एक्चुअली इज इक्वल टू दिस थिंग, मतलब tan phi is equal to 3/4, right? So yeah, you are moving from that, got it. So tan of nahin, so that's just 3/4, right? And you want this thing. Okay, let's do it. So -1/2 cosine of phi plus theta, which is 3/4. Wait, nahin, cosine kya hoga? Just cosine is 4/5. 4/5 and then just approximately 1 minus, just sine theta term, okay, that's what we want. Just minus sine of this guy, just 3/5 sine theta, it's like approximately theta. And then यहाँ पे क्या आ रहा है, plus 2/3 sine some stuff, okay, sine of theta plus 5, which is, so sine theta is, उसमें cosine phi का नहीं, because we just don't want that, like 3/5, just 1, then plus 4/5 is cosine, and then theta, that explains it. So ये से तो मरने वाला है वैसे भी, right? 6 minus, it's not 6 or 6. Oh, this is not making sense. Wait, it's about 3 मर जाएगा, it's 2/5, यहाँ पे negative 2/5 cancels, and you just got this thing, 3/10 theta, and यहाँ पे just क्या है, it's 8/15 theta, right? Yeah, so नीचे just आ जाएगा 30 कॉमन ले लेते, 30 नीचे, ऊपर आएगा 9 plus what, 16, which is 27, so 27. Oh, approximately is that. Somehow it works out. Wait, no, 9 plus 16 is not that thing. 9 plus 16. That's like 25, sorry. Okay, so somehow it's like multiple of 5. I don't know. Okay, this is equal to what? 5/6, huh? तो यहाँ पे just 5/6 चाहिए था. That's all. It's different. So यहाँ पे क्या आएगा? मतलब सब कुछ सेम ही आ रहा है, except GL 5/6, and then that times of 3m. So 5/2. 5/2 mgl theta. That does it. That's why alpha is like of what form? It's just m मर गया, l एक मरा, so alpha is negative, यहाँ पे negative चाहिए, 5/6 और क्या यहाँ पे g/l theta, got it. So just 2 pi square root of 6l/5g, which is C. Next question. Fourth, ये सब करने जरूरी था फिर, I don't know. Next question. Fourth, okay, paragraph. Next, a long, thin, slender, vertical wire has net positive charge lambda per unit length. In addition, there is a current I in the wire. A charged particle moves with speed u in the straight line trajectory parallel to the wire and at distance r from the wire. Long, thin, vertical wire has net positive charge lambda per unit length. In addition, there is a current I in the wire. A charged particle moves with speed u in straight line trajectory parallel to the wire and at distance r from the wire. Got it. Assume that the only forces on the particles are those that result from the charge on the current in the wire. U is much less than C. But इसमें current तो है ना, so there's a current I in the wire, तो magnetic charge, magnetic field भी रहेगी ना इसमें. Oh, अच्छा, charges on and current the wire. U is much less than C. Okay, got it. If the charge of particle is positive, the current in the wire should be the same as that of the velocity of the charge. अच्छा ये okay, throughout it's just a straight line trajectory you are saying. Got it. So like U in that direction, जो भी इसका Q होगा, it's U over there. Okay, cool. So इसमें electric field ऐसी जा रही होगी, which is like what, 2, और it's like distance r, right? This is lambda, ऊपर current जा रहा है, I'm assuming parallel to the wire and the distance r, right? Addition, okay, it's assuming r ऊपर जा रहा है. It's like what, 2k lambda upon r is that field. So that times of Q जो भी है, that's in this direction, and then because of magnetic field, just magnetic field कितनी होगी, just guess that 2 pi r times magnetic field is equal to mu naught I believe. So magnetic field is mu naught upon 2 pi times, okay, whatever. You don't actually want it, you just want magnetic field times u, this direction, so u cross is just in this direction. Okay, got it. So magnetic field times u, right? Or like QBU, that is what, mu naught I upon 2 pi r, that's magnetic field, Q and then U. This has to be equal to ये चीज, right? I believe so. 2k lambda upon r Q. तो मर जाएगा just this thing. So ये क्या दे रहा है? Q naught upon 4 pi. ये r मर रहा है. So it's like for any r ये काम कर जा रहा है. Ah, well that's weird. And this is equal to what? Okay, so like lambda of I is equal to k lambda. So you know lambda is a function of I now. Whatever. Right. Okay, if the charge of the particle is positive, current in the wire should be in the same direction as that of the velocity of charge. Charge of the particle is positive. फर्क नहीं पड़ता चार्ज क्या है. Current in the wire should be in the same direction as that of the velocity of charge. Interesting. It doesn't matter U positive की negative. I mean, wait. Okay, U is right. That does matter. So अगर I ऐसा, if I is negative, it won't be negative. You can see that. ठीक है ना? Then this is the thing. So yes, I जो अपन ने draw कैसे I is along U. Current the wire in the same direction as that of the velocity of charge. Yes, so A is correct. और क्या है if the charge of the okay current in the same direction. So B is also correct. Wait, तो ये multiple choice है क्या? Wait, okay, इसमें at least single correct होगा. Okay, whatever. The direction of the current in the wire is opposite to the velocity of charge with respect to the sign of the charge. Oh, okay, so it's like D is the only correct option because probably just yeah. Yeah, it is the sign of the charge. So D. Next question, fifth. Fifth is suppose that the current in the wire is reduced to I upon 2, which of the following changes made simultaneously with the change in current can be done if the same particle is to be remain moving in parallel to the wire. Doubling the charge per unit length of the wire only. Well, yeah. Doubling charge उससे कुछ नहीं होगा. Doubling the distance of the wire. Okay, that also got cancelled for some reason. Doubling the speed of the particle. Once again, okay. There is this U actually. I guess I missed that somewhere. So there is this U actually. जो कि cancel नहीं हुआ. That's me not I. Yeah, that's a U. Got it. So doubling the speed of the particle that will work. Doubling the charge of the charge per unit length of the wire. Wait, नहीं तुमने क्या किया? I को double. अच्छा I को half कर दें. Lambda should be half. Okay, so D is correct. Sixth. Sixth is okay. When decay beta minus okay, an electron capsule, it is known that this thing has a half life of 12.8 hours. So the mass of this thing is oh shit. लंबा होने वाला है. Okay, what is the half life for electron capture? तो तीन तरह से डीके हो रहा है. राइट. सो एक पर्टिकुलर एटम डीके हो गया तो फिर अपन उसको वापस कभी यूज नहीं कर सकते. राइट. ओके, हाफ लाइफ ऑफ ये चीज. ठीक है, इसकी हाफ लाइफ अपने को दी हुई है एंड इसकी 40% प्रोबेबिलिटी है, इसकी 20% ये. इट्स लाइक गॉट इट. सो कैसा करना पड़ेगा तो बताइए. के इज जस्ट नेचुरल लॉग ऑफ 2 अपॉन टी हाफ. और ये जो k है यू कैन स्प्लिट दिस इनटू डिफरेंट वेज. सो अपने को चाहिए फर्स्ट ऑफ ऑल हाफ लाइफ ऑफ इलेक्ट्रॉन कैप्चर. राइट. और क्या है वैल्यू ऑफ बीटा माइनस डीके. ठीक है, आई मीन दैट इज ओनली डिपेंडेंट ऑन द masses, so no big deal. This initially this many atoms, what is the initial radiation energy is produced to beta plus decay. अपने को बीटा प्लस डीके अभी लगने वाला है. ओके, व्हाटएवर. सपोज probability of क्या some certain reactions like x, p बोल दो, you know p times of k, that is p natural log of 2 upon t half original. राइट. ओके, इसका मैं कैपिटल टी हाफ लिखता हूँ सच दैट समझे कि टोटल है. राइट. या बट गेस व्हाट, pk is the new rate constant for you know वो particular reaction which happens to be like natural log 2 upon t you know अच्छा अपने को k भी एक्चुअली ढूंढना ही पड़ेगा ना. So we need some nice values for this thing. 12.8 hours. That's not going to be good. Natural log of 2 upon this guy, huh? 6.4 something. ठीक है, जो भी है, नेचुरल लॉग ऑफ 2 अपॉन टी इज इक्वल टू दिस, क्या नेचुरल ऑफ 2 मुझे टी इज इक्वल टू टी हाफ अपॉन दी प्रोबेबिलिटी, राइट? सो व्हाट इज द हाफ लाइफ ऑफ इलेक्ट्रॉन कैप्सूल के लिए स्मॉल टी हाफ लाइफ इलेक्ट्रॉन कैप्सूल की प्रोबेबिलिटी कितनी है? So 40%, so divide by 40%, right? Yeah, 0.4 divided. किस चीज को अपन half life is just 12.8 hours, right? 12.8 hours upon 0.4 is like 128 upon 4, which happens to be 32 hours. So B is correct. और क्या है? What is the Q value of beta minus decay? I mean, ये तुम बाद में कर सकते हो ना. What's the big deal? इसमें beta plus decay के लिए भी देखना पड़ेगा. What's K because of beta plus decay? For that, you just need this thing. Okay, probably, yeah. ठीक है, this is a lot of calculation anyway. What do you want? 6 तो हो गया, 7 क्या है? What is the Q value of beta minus decay? कहाँ मर रहा है? Beta minus decay, it's like कैसा होगा? Just copper 2964 that gives beta minus, मतलब कि न्यूट्रॉन का प्रोटॉन प्लस इलेक्ट्रॉन हो रहा है, राइट? और या दैट इज बीटा माइनस पार्टिकल्स ऑफ कोर्स. जस्ट एक प्रोटॉन मर एक न्यूट्रॉन मर के प्रोटॉन बन चुका है, लाइक 30 यहाँ पे जगह स्टिल 64, एंड नाउ इट्स व्हाट, इट्स जिंक एंड प्लस एन इलेक्ट्रॉन प्लस एंटी न्यूट्रिनो, इसमें लिखते नहीं आता मुझे. ओके, निकल का दिया है, दैट्स लाइक फॉर बीटा प्लस, ठीक है, आई गेस. ठीक है, सो जस्ट वांट, या देयर टू देयर. कॉपर का कितना है? बट देन ये जो रहेंगे, ओके, यू आल्सो नीड द मास ऑफ एन इलेक्ट्रॉन बाय द वे, because the electron yeah, it does matter as well, right? Q value of this, I mean, I guess we can, okay, in AMUs though, electron in AMUs, the electron can like 9.3, sorry, 9.1 times 10 power negative 31, right? That's in yeah, SI units kg, I guess, and then it's like 1 AMU is how much? Is like who cares about 1 AMU? Just divide by what? 1 gram upon that, right? Just, the thing. This times of, I get this number just 2, okay, 6.2. So that was like 6 times 10 power 23. और ये होता है per gram or something, right? So 10 power negative 3 already, actually just 10 power 6 something. I should be doing it. Yeah, I guess so. So yeah, all right. मतलब कि this is our in AMUs, right? Well, yeah. तो ये 10 power something कितना, 10 power negative 5, and then just got this thing approximately 9 बोल दो इसको, 9 times 6 is just 54, like 5.4 times 10 power negative 4 जो भी है, right? और ये सब अपन, okay, इसका जो difference रहेगा, how much is that? 63, हाँ वो ठीक है, वो 64 whatever. Just want इसका mass minus इसका mass, because नहीं, उसका you want this का mass minus इसका mass plus इसका mass, that's the Q value, right? Or was it in this times of C square or something? अच्छा, you want in energy, ठीक है ना, फिर well, करना तो पड़ेगा. So what do you have? 92977 minus ये 92914, so 0.0006 and 3, which is like 1 2 3 4 5, 63 times 10 power negative 5 is like 54 times 10 power negative 5. So we just have to subtract this from that as well, right? Yes. So kitna just 40 minutes or whatever, it's like 10 times 10 power approximately, right? 10 power negative 5, which is 10 power negative 6 के order में आने वाला है. That's in AMU, and you want in energy is like this times of 931 mega electrons, approximately कितना 1000 mega electron volts. So 10 power negative 3 mega electron उसके पास में आना चाहिए, right? Which means उसके order में at least. So ये चीज़ है क्या? 10 power negative 3 is like 587 times that. Okay, that is too big. Okay. It's like a mega electron volts तो supposed 10 power negative 3 के around चाहिए अपने को. This is just too big. ये सारे बहुत बड़े हैं. I guess B is the best you can do. So like 77 times 10 power negative 3 mega electron volts, still weird. Yeah, it's still weird. Oh shit, it's not 10 power negative 6, it's just 10 power negative 4 over there because यहाँ पे 10 आएगा ना. Oh god. So it's just 10 power negative 1 के ऑर्डर में चाहिए, which is like point 1 के पास में, point 1 के पास में कौन सा आता है ये, right? Because ये तो ऑलरेडी बहुत बड़ा है, ये भी बहुत बड़ा है, बहुत बड़ा है. So B is the answer. Next question. Right, I guess so. Next question. 8. If initially there are this many atoms of this, then what is the initial rate at which energy is being produced due to beta plus decay? Once again, बहुत सारा calculation है इसमें. Beta plus decay you are saying, हाँ? Energy. पर अपने को वापस वही सब करना पड़ेगा यार, ये फालतू है ये सब. I don't want to be doing this. ऊपर से अपने को एंटी न्यूटन का मास नहीं पता है, so how do you even figure out anything? So just leave it, right? Yeah. Paragraph question 9 to 11. Okay, rod of mass m. Just skip कर रहा हूँ. 9th. A rod of mass m length L is free to rotate in a vertical plane about a fixed horizontal axis O, passing through one of its ends. A small sphere of mass m upon 4 hits the rod elastically with horizontal speed v naught. This is 12 upon 3 from the, okay, before collision the rod is set in vertical plane, the vertical position, whatever. Maximum angular deflection of the rod from the I node. Okay, so it's just elastic or what? Elastically got, that's good. So मैं वो equation discuss करता है, just what. Um, so inelastic के लिए क्या होता है, just finals like mr squared plus inertia जो भी है that times of omega is equal to mv naught r रहता है for inelastic, but then for elastic it's just 2 mv naught r. So using that again figure out what omega should be, right? Yeah, okay, cool. And then also क्या था for elastic you just have v, so inelastic you just have this thing v is equal to, or like was that thing or not? So final inertia, okay wait, you just got omega, right? So omega 2 mv naught r square आ जाएगा in that case. over 2 तो पहले था नहीं, this thing अपॉन mr square प्लस i रहता है यूजुअली. इस केस में तो जस्ट mr squared minus I upon mr squared plus I not m squared r, right, that terms of v naught. So अपने को v मिल गया and v is in the positive direction, so जहाँ पे v naught था that's the positive direction. So ये अपने दो equations which we know of, right? Maximum angular deflection of the rod from the vertical position after collision is omega ढूंढ लो, or maybe don't find omega because okay whatever, just I omega, maybe I omega is the best. Wait, you know the angular momentum, right? Oh, you do know the angular momentum. This is what, like, it's just angular momentum का square upon 2 times the inertia. That's our energy, right? And this energy will be the same as. But okay, वो combined is not okay. It's not so easy to just do that. Half I omega square is probably the best you can do right now. So ठीक है ना, ऐसे करते हैं. Half I omega square. I is just I, then mr squared plus I. R is of course just 2L upon 3 in this case. ये मार्क्स का m अपॉन 4 है. इनर्शिया आई गेस इज जस्ट द बेस्ट कि अपन स्टार्ट करते हैं इसमें पुट करने का, राइट? सो m अपॉन 4 r स्क्वायर की जगह जस्ट 12 अपॉन 3 का स्क्वायर, जस्ट 4l स्क्वायर अपॉन 9 प्लस inertia of this complete is just mass m length l like ml squared upon 3, the times of omega is equal to 2 mv naught r, which is like 2 times इस केस में m upon 4 v naught, and then r is what, just 12 upon 3. Got it. Simplify करो इसको. So what do you get? ml squared 1 upon 9 plus 1 upon 3 omega is equal to mv naught l 1 upon, okay वो तो मर गया, just 1 upon 3. Got it. It is like this कि ml squared, oh, m तो मर रहा है anyway और एक l भी मर रहा है, right? So omega is equal to 1 upon 3 upon 1 upon 3 plus 1 upon 9, that times of v naught upon l. ये क्या है, just 9 से मल्टीप्लाई करो, because 3 upon 1 plus 3 is like 4, 3 upon 4 v naught upon l, that's omega. फाइनली एक तो चीज अपने को मिल रही है, राइट? निकालो एनर्जी कितनी है. वेट, once again just try to do it correctly, just like what, ml squared upon 3 omega, okay, it's like half omega square that is equal to initial energy to final energy. Just suppose तुम थीटा से ऊपर गए, then like 1 minus cosine theta, right? Okay, 1 minus cosine theta will be the thing, and then we spot L upon 2 times M and G, of course. Yeah, that makes sense. So L upon 2 मरा, is just ये गायब हो गया. Good. M मर गया, just what? L omega squared upon 3 is equal to 1 minus cosine theta times G. Well, that's it, right? So क्या 1 minus cosine theta is equal to omega square L upon 3G. We know omega क्या है, at least, which is what? इसका square, which is 9 upon 16, तो वो just 3 upon 16 जाएगा, 3 upon 16, and then you have V naught squared upon LG. So cosine theta equal to half, ठीक है, 1 minus 3 upon 16 V naught squared upon LG cosine inverse. C is correct. और क्या है? 10th velocity of the sphere just after collision. You figure that out, I guess. और क्या है? Maximum magnitude of the impulse of the rod exerted by the axis O during the collision. O, okay, तो O ने जो impulse आ रहा, got it. On the rod though, wait. Right, so just, horizontal अगर impulse रहेगा, vertical तो कुछ नहीं हो सकता, of course. So that impulse, ठीक है ना? Just try to do it. What do you get? At least now we know कि omega क्या है, so I guess that's progress. Think about it. Right, it's like omega times center of mass. Okay, yeah. So ml upon 2 times omega. That's just the new force. Oh, sorry, new momentum this has. So वो momentum इसको डालना पड़ा होगा. Otherwise कैसे होगा बता? Right. Wait, नहीं, इसमें already momentum भी तो पड़ा था. So हाँ, that's interesting. टॉर्क इक्वेशन ही एक तरीका है, I guess, because yeah. One thing in momentum तो ढूंढना पड़ेगा. That's just not good. Must be some other way. Some other way. Is there some other? I don't think so. ठीक है, अपने मोमेंटम को ढूंढना पड़ेगा. That's the only way. ठीक है, so for that first of all you need इसकी फाइनल v वैल्यू क्या होने वाली है, right? So what's the v value? It's just mr square is like m upon 4. just मैं values put कर रहा हूँ, like 1 upon 4 r के जब 2 upon 3 is like 4 upon 9. Actually it's 1 upon 9 everywhere, right? Yeah, 1 upon 9 minus 1 upon 3 upon 1 upon 9 plus 1 upon 3, which happens to be just 1 minus 3 upon 1 plus 3, so like just 2 upon 4, 1 upon 2 v naught. So v is just 1 upon 2 v naught, right? Which is b. Okay, what's 11? Now we know the momentum. Momentum कितना है, मतलब जो impulse इसने डाला होगा, इस mass ने. Wait, is that? But मैं positive बोलूँ कि negative? This is kind of weird. नहीं, but v is जो भी है. Assume this is actually a positive axis. Anyway, momentum कितना, just इसमें impulse पड़ा is just m upon 4 था नहीं? Right, it's like m upon 8 v naught was already 1 upon 2. Got that. And it's at 12 upon 3, so its distance from this center is what? So center से distance कितना है? Your momentum is like जो भी है, I mean we just want to make it anyway, तो अपने ideal case में करते, it's like this, and then momentum suppose अपन ने ऐसा not like this, which means you know what, rotate it like this, right? So p आ जाएगा, and then यहाँ पे m upon 8 v है, at what distance from this guy? It's just 1 upon 6 I believe, because this is just 1 upon 2 minus 1 upon 3. Yeah, it's just 1 upon 6 L. This is like L upon 2. So what do you have? P is equal to 1 upon 3 times was वो कट जाएगा, just m upon 8 v naught. Oh नहीं, अपने को omega 0 में निकालना है. We want this, right? Okay, let's do it correctly. P L upon 2 plus mv naught L upon 48 is equal to inertia times ये वाला omega, which is, what's the inertia by the way? Just ml squared upon 3. Distance of this guy is, yeah, ml v naught upon 4. Got it. So that's one thing you need. हाँ, बस इतना काफी है. Figure this out. Yeah, okay, that's the final question, right? So क्या हो जाएगा, just pl, अच्छा l तो हटा दो, l गया, l गया, l गया. P plus mv naught upon 24 is equal to mv naught upon 4. So P is equal to what? Mv naught upon 4 common, just 1 minus 1 upon 6, which is like 5 upon 6. So just 5 mv naught upon 24. And that's not there, of course. Uh, seriously. Seriously though. Just happens to be like, yeah, 3 minus 1 upon 3 plus 1. Shit. Shit. अपने कुछ भी गलत कर दिया. Go back. तो इतना बैक तो जाएगा नहीं, I guess. Okay, तो omega was this thing, right? And जो अपन ने कैलकुलेट किया था वो कितना था? mr squared, which is like 1 upon 4 over just 1 upon 9, 1 upon 9 is 1 upon 3 upon 1 upon 9 plus 1 upon 3 v naught, which happens to be 1 minus 3 upon 1 plus 3. So negative 1 upon 2 v naught चाहिए. P is not this thing, it's instead 3 upon 8 v naught. Pretty obvious, right? तो इसका आंसर क्या आएगा? Just D. So 10th का आंसर D आएगा in fact, and 11th का क्या आएगा? So यहाँ पे 3 upon 8 है. Okay, so PL upon 2, फिर यहाँ पे 3 upon 8 आ रहा है, which means कि 3 mv naught L upon 6 तो वो मर गया, just 1 upon 16. This is equal to ये चीज like ml v naught upon 4. Yes, yeah, this should work. Oh, yeah, this should work. Okay, let's try it out. Just p plus mv naught upon 8 is equal to mv naught upon 2 चाहिए by the way, इसमें वो भी मेरा गलत हो गया. Okay, interesting. ठीक है, then this is the thing. Oh shit. Inertia about center of mass, not ml squared upon 3, should be ml squared upon 12. तो यहाँ पे एक्चुअली 16 आएगा. हाँ, equal to 0. Oh, interesting. So A is in fact correct. 12. 12 is okay. Two thin convex lenses L1 and L2 having focal length respectively are placed coaxially as shown in plane mirror placed normal to the axis. At a point, luminous object O on the axis shown light rays emitted by A first pass through L1 L2 respectively, then reflect from M. Okay, reflected rays pass through L1 L1 respectively. ठीक है ना, final image is formed at what point? बड़ा लंबा होने वाला है. Optical center of L1 to the left of whatever. Final image निकालनी है अपने को. ठीक है ना. और क्या another object P kept the same. वो ओपन कर लेंगे, तो ये नहीं करा. Just God, 30 centimeter, right? It's like 45. करो करो करो, करते ही है. Okay. So 1 upon V minus 1 upon U equal to plus negative minus negative 1 upon 45 and then plus 1 upon 30 पहले इसके लिए is like what? Negative, okay, 1 upon 15 common later, just what? Negative 1 upon 3 plus 1 upon 2, which is just 1 upon 6. So just 1 upon, yeah, 90 equal to 90. 90 away from that. So exactly यहाँ पे at the optic center. Oh, if that's 0, then ये infinity over there, then this must also be 0, right? Exactly. So just passing through it, nothing is happening really. So yeah, I mean that's the thing. So वहाँ से just passes through this mirror. अब ये जो इसकी image बनेगी, it's like at this point. So it's at negative, yeah, okay, it's at this point 80, right? Exactly. Okay. नहीं, तो 180, sorry, 180. अब इसके लिए वापस करना पड़ेगा 1 upon v. अब पॉजिटिव डायरेक्शन ये ले रहे हैं अपन. ओके, 1 upon v इज इक्वल टू, अब यहाँ पे जस्ट नेगेटिव 1 upon, yeah, okay, negative 1 upon 180 प्लस 1 upon 60. ये कितना लंबा हो रहा है यार. Just 1 upon 60 just got what? 1 minus 1 upon 3, it's like 2 upon 3, just 1 upon 90 once again. That is weird. So v is 90 once again, ये यहाँ पे आ रहा है, and then it just, okay, it's at the optic center of L1. A is correct. और क्या है between L1 and, okay, another object P is kept at some point to the left of L1 such that its final image coincide with the object P. left of L1 such that its final image coincide with the object P. Distance of object P from L1 should be. Seriously though. Q to me is a I guess like retraceability or something. ऐसा तो कोई रेडियल मतलब रेडियस रहता नहीं है रेडियस will be infinity तो what if like okay what if this is at infinity so it should be yeah image coincides exactly right so दो cases हो सकते हैं एक होता है जब inverted बनती है that's at when you have pole से वापस reflect होते हैं in other cases like कि तुम yeah parallel rays है so just कि कहाँ से आ रहा होगा इसका focal length क्या 60 so it's just like from this guy like okay 30 से right so this should be 30 अगर 30 पे image बन गई then just like parallel is parallel rays आ जाएगी फिर ये वापस जाएगा it's just retrace जाएगा बराबर so yeah just want that to be happening like 1 upon v equal to 1 upon u oh अब अपने को v पता है ना v is just what 30 minus 1 upon u equal to 1 upon f कितना है 30 as well oh u should be infinity so that's d uh okay so point object नहीं है we are assuming so at infinity ठीक है I guess d does look correct infinity पे रखते हो it's like that's at 30 फिर oh it's like a telescope but with a mirror so it's 30 फिर 60 से okay parallel वापस reflect हो yeah okay got it so okay I don't know तुम coincident नहीं बोल सकता है because ये infinity हो जाएगा maybe some other way जो भी है next question ज़रा टाइम बर्बाद करने की कुछ नहीं हो रहा the minimum value of what is it delta for which the lower block loses contact with the ground is mass of the upper block is m of the block of 3 and the upper block is depressed down from its position by distance okay and released at equal to 0 value of del for which the lower block loses contact with the ground okay got it so फिर वो del जब ऊपर जाएगा that's when you have the maximum force right but yeah it's like what mg तो ये मतलब उस पे पुश कर ही रहा था and oh it's like what it was pushing right not pulling got it equal positions जा रहे ना it's what अब जो force लगने वाला है tension in this thing right it's like what k times इसको मैं x बोल दूं क्या yes so k times of x हमारा जो ऊपर गया yeah and minus of जो already compression था because of that is mg yes so this in fact ये जो चीज रहेगी this should be actually yeah okay normal force 0 जाना चाहिए for it to be lifted up so this should be equal to 3 mg so x या फिर del जो भी है like 4 mg upon k which happens to be c next question 15 15 is value of del for which the minimum normal reaction at 3 meters from the ground is mg minimum normal reaction on 3m from the ground is okay once again the same thing ki kx minus mg minimum normal reaction right that's gonna happen जब ये इससे ऊपर रहने वाला है topmost point yeah it's just kx minus mg that's the thing of course this is equal to so इसका अगर मैं फिगर नहीं ये फोर्स इसके ऊपर लग रहा है ऊपर और क्या लग रहा है इस पे ग्रेविटी नीचे 3 mg and then normal force is mg so combined is 2 mg this should equal to 2 mg so kx is equal to 3 mg upon okay x is equal to 3 mg upon k which is a okay next इसका मास m था ना but yeah two projectiles are thrown simultaneously in the same plane from the same point. Their velocities are v1, v2 at angles theta 1, theta 2 respectively from their horizontal and answer the following questions. Same plane, same point, okay, simultaneously, same time. The velocities are v1, v2, theta 1, theta 2, okay. The trajectory of the particle 1 with respect to particle 2 will be a straight line, God. Everyone knows. So please correct. ये तो वापस J main types आ गए. 17. v1 cosine theta 1 equal to horizontal velocity same इनकी. Just the correct option. One particle will remain it may be below or above the other particle. Sorry. Yes, throughout its motion at least वो above रहेगा. Trajectory of one with respect to other will be a vertical straight line. till they मतलब till one of them actually goes down, right? With the incorrect statement. Okay, तो एक तो correct है, B correct है, both will have the same range. That's wrong. Time period. Okay, so C is wrong. Next question. 18. According to Newton's law of cooling, okay, temperature is what? But case of constant body cools from 50 to 14 5 minutes to surrounding temperature is 30. This is not for a time like cool to 30. So with respect to 20 कितना है? It's like 30 to 10, right? नहीं, 30 to 20 I guess. 20 in 5 minutes. और अब क्या करना है? अब 30 डिग्री सेल्सियस करना है, just like just 10. So in what time, right? Well, yeah. So okay, क्या रहता है? Just natural log of 3 upon 2 equal to k times of 5 minutes, and natural log of 2 is equal to k times of ये जो भी time required, like t upon 5 minutes is equal to natural log of 2 upon ये चीज, which okay I guess you can also write it like this thing, log base 10 of 2. तो मैं अब वापस को गलतियां नहीं करूंगा कि natural log एक्चुअली इवैल्यूएट करो ना, log base 3 minus log base 2, right? So like t is what 5 minutes and ये cheese, which I guess is approximately just 0.3 upon क्या ये क्या होगा 0.477 होता है, ओके 0.478 अप्रॉक्सीमेट कर डालते हैं इसको, हु केयर्स 0.477 इज गुड इनफ, माइनस 0.3 once again, or the times of 5 minutes. So yeah, 5 just because 3 minutes में रहेगा anyway. So what is this, like 3 upon 1.77 is 5, I guess. Yeah, wait, isn't like square root of 3 also 1.77 something? So ये just square root of 3 है basically. Yeah, whatever, it's like what 15 upon 1.77 something less than 1 approximately जो भी है, 15 upon 2. Okay, this is approximately what 5, 15 upon 2, 25 upon 3, 1.77, right? Approximately, you know what, just put it as 1 up 1.8, you know, it's like what 15 upon 18, which is 5 upon 6, so approximately 5 upon 6, 15 upon 2, should be less than that at least. Oh, okay, 1.8, that's like 150 upon that, 50 upon 6, which is, ooh, that's kind of a weird thing actually. Further time required, right? I mean, that's the thing. So it went from 20 to 10. Yeah, that's it. That's the equation, of course. That's log of 2 upon log of 3, which is just this thing, right? It's got to be like that, 5 upon 6 approximately, which इनसे कोई भी काम नहीं. Okay, 50 upon 6, big deal. 25 upon 3, yeah, so C is looking correct. Next 19. सीरियस तुम्हें ऐसे अप्रोक्सीमेशन करने को लगा रहे, और मे बी तुम्हें जस्ट लीनियराइज करना था, मतलब यू नो या कि वो रेट ऑलमोस्ट अप्रोक्सीमेटली सेम रह रहा है, समथिंग लाइक दैट, बट नहीं रह रहा ना, तुम्हें पता है जस्ट ये ऐसा होता है. एंड देन या इन द प्रीवियस क्वेश्चन व्हाट वाज द टेंपरेचर 5 minutes आफ्टर रीचिंग 4 डिग्री सेल्सियस, उसके और 5 मिनट बाद, हाँ राइट. ओके, इधर से 220 कितना हो रहा है, लाइक 30 से फिर 20 अब कुछ तो भी टेम्परेचर आ जाएगा टी, एंड देन 5 मिनट, तो वो जो रेशियो है लाइक या जीपी ऑफ कोर्स तुम डिवाइड करो 2/3 से, इसको 2/3 से डिवाइड करो लाइक 40 upon 3, but then actually this thing plus 20, right? It's like 60 plus just 100 upon 3. Okay, this was easy enough, so B is correct. 20. Okay, a tube of length L, radius R carries steady flow of a fluid whose density is rho viscosity. The velocity v of flow is given by this thing where r is the diameter. Okay, I think ये कहीं देखा था मैंने. हाँ, I know. Poisson's equation में जो होता है ना वैसा है. Large distance of flowing fluid from the axis, then volume of the oh, that's it. Volume of the fluid flowing across the section. That is actually very easy, right? मतलब just integrate करना है. What else, right? Yeah, so क्या 2 pi r dr times v, which is like this thing, v naught squared over हो गया ये चीज, and it's going from what to what? Integration from r equal to 0 to r. There you go. That's your, yeah. It's 2 pi v naught, or one kind of like just r over there minus r cubed. So just r upon 3 or something like 2/3 r है 4 upon 3 pi v naught r square जो भी है. Oh, that's not there. Okay, something's going wrong. Oh shit, वहाँ पे r cube है. Okay, okay, something's definitely going wrong. Just 2b v naught बाहर, नीचे वो r आएगा नीचे. Yeah, like r minus r cube upon r squared integration from 0 to capital R. So r squared upon 2 minus r squared once again upon 4 in this, like r squared upon 4 basically. Just what? Pi v naught r squared upon 2. So b looks correct. और क्या है? Kinetic energy of the fluid within the volume. Seriously. Okay, कितना लेंथ कितनी तुम्हारी? ठीक है ना, करते हैं whatever. So integration, एक वॉल्यूम आपका क्रॉस सेक्शन चाहिए, is 2 pi r l dr. That's the cross section, of course. Okay, the volume, sorry, and this times rho, it's our mass. Half करना है वैसे भी is this thing, right? So pi r l rho dr. This thing is basically half m ka factor. Then you want v squared, so just that. If you v naught squared, and then you got this thing 1 minus r squared upon r squared to the power 2 or something. And you want to do this from 0 to capital R. Got it. So to show you what volume is flowing, yeah, kind of just figure it out, right? Okay, pi l rho v naught squared, and you got this thing integration of r, and then ये सब, which is just 1 minus 2r squared upon r squared plus blah blah blah, just r power 4 upon r power 4, and then like dr, from 0 to r. So पहला r का integration is r squared upon 2, then minus cube, so power 4 upon 4 is just 1 upon 2 आएगा इसमें नहीं, yeah, just r squared upon 2 once again. Got it. तो ये just r power 5 like 6 आ जाएगा इसमें. Got it. Just r power 2 upon 6, ये तो मर गया, just this thing, which is like what? Yeah, 1 upon 6 pi l rho v naught r squared. Oh, not square b squared. Okay, so a looks correct. Next question. You know what, we should stop here because 20 ऊपर अपन कर चुके हैं. This is it then. I'll see you guys next video. Bye.